All right, it's recording. Chain rule, your bread and butter. Okay, so the first rule that most students memorize is the power rule. So anything like y equals x squared, the derivative of x squared is 2x. So we know that, right? That's the main one when it comes to power functions. Then the next one is your chain rule. Chain rule can be embedded in every single other function. So if you don't get the chain rule, then the rest falls. Yeah? And you'll find that in exam 1, the very first question is often a chain rule of some form or a product of some form. But even if it's a product rule, you still need chain rule within it. Yeah? So this is a very important rule. And one of the ones that most students relate to is this one. Delta y, delta x can be broken up into delta y, delta u, this here, as a new term, new function that we're replacing. And if you multiply them two together, in a way, it's sort of like they cancel out and you get to y dx. All right? The actual formula that you get on your formula sheet looks like this. Okay, so most students don't look at that, or they don't know what that is, and that is in your multiple choice sections, which is worthwhile knowing. So one of the questions I'm going to test you to see if you know how to use this bit. We're going to practice today to revise on how to use chain rule, when to use chain rule. Jaden, Albert, thank you. When do we use chain rule? How do we use chain rule? And then get you to practice so that you get a feel. So on the second page of that, you'll find I've put all together all the exam questions. That is chain rule. It's all question ones for you to try. But before we do, let's do a logical approach. How do we know when to use chain rule and how do we look for it? Let's start off with this one. If I gave you y equals x cubed and I said, find the derivative. We know the derivative is equal to what? Can I please have Xavier? Beautiful. The rule was really simple. We say that drop down the 3, subtract the power by 1. That's a power rule. When it's x cubed, we know. How do I change this into a chain rule type problem? Is I take something familiar and then I make it less familiar. So if you look on the one that I've just put over here, it's still the same thing. I still have something cubed. The problem is this. The 4x squared minus 2x is what I don't like. Had it just been a letter x, you knew how to do. What have I made different? I replaced that x with a 4x squared minus 2x. So how do you know when you use chain rule? Is when you can see a composite function. A function within a function. Write that in. How do you know when? So write when. Composite function. When you can see a composite function or a function within a function, that's a hint. That's a hint when you use that. Now let's use this. So, y equals 4x squared minus 2x all cubed. This looks really complicated. The other way that you would have done it in year 11 is you would have expanded that entire thing, get the individual terms and use power rule. That takes too long, especially if I did to the power 33. That would have been impossible to do, right? So chain rule saves us time by saying this. Okay, you don't know this. So why don't we make it something we do know? See, in your formula, that u is make up something. So this is what we do. We say, all right, let u, so I'm introducing a new variable. I say, what if I let u equal to what I don't like? So the thing I don't like is the 4x squared minus 2x. So why do I do that? If I do that, what changes is the equation. The equation is now y is equal to, and instead of this crazy thing, I've changed it to u to the power 3. That is more desirable. All I did was I simply took this function, 4x squared minus 2x, and I called it a third variable, which I called it u. What's nice is now that I got y in terms of u, when I find the derivative, this is delta y with respect, not to x anymore, but this is with respect to u. This one, like Xavier said before, we do know what the derivative of u cubed is. It's just like find the derivative of x cubed. That should give you 3u squared. According to the chain rule, if I know what delta y delta u is, I just need to multiply that 2 delta u delta x over here. I've got delta y delta u. I'm just missing delta u delta x. I multiply those two together, I can find the derivative. So here, I've got delta y delta u. How do I get delta u delta x? Well, it's right here. Derivative of this u function in terms of x, that's my delta u delta x. What is the derivative for 4x squared minus 2x? Let's go with Ian. Yep, what's the derivative? Beautiful. Now I've got both of them. I've got delta u delta x. I've got delta y delta u. So according to the chain rule, delta y delta x is equal to delta y delta u, which we have, multiplied to delta u delta x, which we also just found out. So together, you have 3u squared multiplied to 8x minus 2. Can't leave your answer here. Why? What's the problem? Albert. The u. I made up u. U was a variable I made up to make my problem easier. So, we need to resubstitute what u was. U was equal to 4x squared minus 2x. So my final answer should be 3 bracket 4x squared minus 2x all squared multiplied to 8x minus 2. This is called the chain rule. So the chain rule takes something that's familiar that you know, and then if you can see a composite function with it, your aim is to get rid of that complicated function, the function that you are substituting in. That's the skill. So let's do another practice. Let's look at example 1. Here's example 1. I've got 1 plus x squared all to the power of negative 3. What's the problem? Where's the function within a function, Rango?
You've got 1 plus x squared is one of the functions, and then you've got u to the negative 3 is another function.
Beautiful. Can you guys see that? This is a function within a function. Had I got, instead, y equals u to the power of negative 3, you would have been able to do this much easier using a power rule. Problem was the 1 plus x squared. So instead, what we do, we say, well, let's let u equal to 1 plus x squared. That means the derivative, which is delta u delta x, so in respect to x, must be, what's the derivative of 1 plus x squared? Let's go with Emily. Very good. So we get 2x, derivative of 1 is 0, derivative of x squared is 2x. But then that means the new function, y is not equal to 1 plus x squared to the power of negative 3 anymore. It is now u power of negative 3, which we like. What's the derivative of u to the power of negative 3? Y equals u to the power of negative 3, Serena. Beautiful. So if we put it all together, I've got delta y, delta u, I've got delta u, delta x. According to the chain rule, it should be negative 3u to the power of negative 4 multiplied to 2x. Problem is the letter u. We made that up. Make sure to put it back in. But also remember, don't leave your answers with u and negative power. Don't leave your answers with that negative power 4. So here, u was equal to 1 plus x squared. This should give you negative 3, 1 plus x squared all to the power of negative 4 times the 2x. But when you multiply, remember, this negative power, bring it down. So if you bring it down, we now have negative 3 over 1 plus x squared to the power of 4 times the 2x, which simplifies to negative 6x on 1 plus x squared to the power of 4. That's a better answer. Sometimes in your exams, sometimes they also make it that you can simplify within the brackets as well. You might need to factorize that. So as you're doing the exam papers later, you'll start to see some questions will get you to do that. So far, so good? Here's a challenge. I want to pause the video. I want you to try out question 3 from your textbook. This is 9E. And then I want you to try question 5, which is a typical exam question, a multiple choice. Looks hard, but it's very simple. But I want you to have a look at it. Try 3 first. So 3 should be very similar to what I just taught you. And then try 5. I'm going to give you roughly, let's say 3 marks, 4. All right, let's make it 7 minutes. 7 minutes is currently 2:46. You've got 7 minutes. I'm going to pause the video. I'm going to walk around to double check how you're doing.